So good day everybody. Welcome to this presentation. So in this presentation we are looking at this topic, sequence and the series. So first thing we are going to start with a sequence. So we can say a sequence is a list of numbers. Okay, it is an ordered list of numbers. For example, you can have a sequence that can be written like 2, 4, 6, 8, 10. So this is an example of a sequence. So this is what a sequence is, an ordered list of numbers. For example, this one. So these terms that we have, these numbers that we have, we call them as the terms. So we call them as terms. So depending with the position of the term, we can say this is term 1, this is term 2, this is term 3, term 4, term 5. Just like that, and then we can have the general term, which we can call the nth what term, because this sequence can continue moving. Okay, so now we have said these are called the terms. Okay, these items, these numbers, we call them as terms. Now these terms can be presented by numbers like the way you have seen. They can also be presented by letters or objects. So each sequence now, it has a specific rule that it follows. Okay, when you look at this sequence, they are starting from the first number. To go to a second number, the difference here is a 2. So they are adding a 2. From 4 to 6, they have added a 2. From 6 to 8, they are adding a 2. So each sequence has its own specific what rule. So let us now look at examples of what sequences. Okay, so under examples of sequences, we have number 1, we can say we have what we call arithmetic progression. We can say AP. Okay, then apart from that, we also have what we call geometric progression. These are examples of sequences, which we can also call GP. Then apart from this, we also have affinity sequence. Okay, we also have infinity sequence. Okay, so as we go further, we will even look at the Fibonacci sequence. Now, these are the examples of sequences that we have: arithmetic progression AP, also have geometric progression GP. So in our discussion, we are going to go deep into these two types. Okay, we are going to go deep into these two types. So we are going to start with the arithmetic progression. So our first one, we are starting with the AP, which is arithmetic progression. So in arithmetic progression, you find that this type of sequence, okay, you find that each term is obtained by adding a constant difference. I gave an example. If you have 2, 4, 6, 8, okay. So if I want to, first we find the constant difference or the common difference. We can call it the common difference. So this common difference is a difference that is passing between 2 and 4, 4 and 6, 6 and 8. It's constant. So this common difference, we can refer to it by using D. D in this case will stand for common difference. So since we have term 1, term 2, term 3, term 4. So how do you find the common difference in an arithmetic progression? To find the common difference in an AP, we say D equal to, we will get the second term minus the first term, or we can say third term minus second term. That is how we can find the common what difference. It's constant. So now in this case, if I get my second term, which is a 4, my first term, which is a 2, and 4 minus 2, our difference will be a 2. Even if I say third term minus second term, I'll still get the same. Again, fourth term minus third term, I'll still get the same. Don't say fourth term minus term 1, then the common difference won't be constant. So that is how we find the common difference. So we are saying in an AP, we find each term is obtained by adding, okay? Each term is obtained by adding a constant difference to the previous term. So in this case, if I want to form this sequence, if I want to continue to forming this sequence, to go to the next term, I'll use the constant difference, which is a 2, and I'll add with the previous what? The previous term. So in this case, I'll say term 4, meaning I want to find term 5. Term 5 is equal to term 4 plus d. So in this case, I'll say my term 4 is 8. The difference is a 2. So the next term will be a 10. So here we have a 10. Just like that, if I want to find another term, so 4, 5, this is term 5. If I want to find term 6, I'll say the same. Term 6 is equal to, so I'll get term 5. Then I add with the difference, okay? The difference, the common difference, which is a d. So my term 5, it's a 10 that you have found. The difference is a 2. So we're going to have a 12. So here we are going to have a 12. So this is one of the basic rules that we can use when it comes to finding of forming the sequence under arithmetic progression. So we are saying in arithmetic progression, each term is obtained by adding a constant difference to the previous term. Okay, an example is this one that I've given. Now, when it comes to arithmetic progression, we must be aware of formulas, because this one consists of formulas. So the first formula that you look at is when they ask you to find the general term of the expression. This general term, we can say the nth term, okay? The nth term or the general term, okay, of an expression. So sometimes they can say find the general term of an expression, which is this one, nth term. So what formula do we use? Okay, we can say nth term equal to a plus open bracket n minus 1 close d. So you must know a stands for the first term, which is term 1. D, this is the common difference, okay, which is this one, the one which I was showing you how to calculate here. So this is the common difference, okay. And the common difference, we said we can find it by saying common difference equal to term 2 minus term 1, or we can say term 3 minus term 2, okay. Then this is the first formula you must know. This n, this is the position of the term, position of term, that is the n. Sometimes they can say, can you find the sixth term? So n is 6, okay. So this is the formula that you must be aware of. Another formula under arithmetic progression is the one that has to do with the sum of terms. It's the one that has to do with the sum of terms. So sum of terms, what formula are we talking about? Okay. Right, so when it comes to finding the sum of the terms, we can use this formula where we can say a subscript n, this means sum, equal to, okay. So this is the formula. You must be well equipped with this formula. So you say n over 2, okay, then open square bracket, 2a plus open bracket n minus 1 cross, then d cross square bracket. So this is the formula that you must know. A is the first term, n is the position of the term, d is the common what? Difference. So these are the formulas. Now let's look at the examples so that we know how we can apply these formulas. All right, so here is our first example. Given that 99, 92, and 85 are the first three terms of an AP, find the sixth term. So first thing, you must take note of the sequence. You have this sequence 99, 92, 85. This is the sequence that you have. So they are saying, can you find the sixth term? So this is term 1, term 2, term 3, term 4, term 5, term 6. So we want term 6. So how do you find the sixth term? So in order to find the sixth term, Remember, we are going to use the general formula of an AP. This is an AP because they have said this is an arithmetic progression. So, how do we find the sixth term? So, to find the sixth term, we are going to say term 6 equal to A plus open bracket n minus 1 cross D. So, this is, I've put T6 here because I'm finding term 6. Now, if we start organizing our information that we have, our data, A is the first term. So when you look at this sequence, the first term is 99. Okay? Then N, I said, is the position of the term. Because the question is saying, find the sixth term. So position of the term is only position 6. So N is equal to 6. Then D is the common difference. Okay? So this common difference, we can find it by saying term 2 minus term 1. So common difference equal to, here, term 1, term 2, term 3. Term 2 is a 92 minus term 1 is a 99. So here, common difference, okay? Common difference is equal to, so 92 minus 99. This will give us negative 7. So our common difference is a negative 7. Now we can substitute. So we can say term 6 equal to, where there is A, we are going to put 99, which is the first term, plus, where there is N, we put 6 minus 1. Where there is D, common difference is negative 7. So I'll say times negative 7. So this multiplies with what is inside here. Okay. So first thing, we are going to write term 6 equal to 99 plus, we can deal with what is inside the brackets. 6 minus 1, this will give us 5. Okay, this will give us 5. So remember, this 5 has to be multiplied with negative 7. So term 6 equal to 99, then 5 times negative 7 to give us negative 35. So plus negative 35, like this. Okay, then term 6 equal to, so here is just a matter of opening the brackets. We write 99, positive times negative, you get a negative, and then you write 35. So term 6 equal to, just subtract here, you say 9 minus 5. This gives us 4. Okay, 9 minus 3. This gives us 6. So this is our term 6, which is x64. So our term 6 is x64. I hope you are following. Okay, so we have answered our question A, this one. Let us now answer our question B. So question B, they are saying you need to find the nth term. Now remember, this nth term, I said, is just the general term of an expression. So sometimes they can say, can you find the general term of an expression? So how do you find the nth term? Remember, this is our sequence that we are using, like this. Okay, so the difference here is we are still using the same. Now I'll say nth term equal to A plus open bracket n minus 1 D. Then my data right here, the data is the same, but what will be different is n. A is equal to 99, which is our first term. Common difference is a negative 7. N, so in this case, n is equal to nothing, okay? Because they have not told us anything to say, find the sixth term, find the seventh term, find the what. No, they have just said, find the nth term. So to find the nth term, what you get is an expression, okay? Where this n will be there in your answer. So we are just going to substitute on A and D, not on N. So where there is A, we are going to put 99 plus N minus 1 times, where there is D, we'll put negative 7. So from here, we are going to write 99, okay? 99. So from here, what is inside the brackets of N minus 1? So we can't simplify this because we have unlike terms. N and 1 can subtract. So what you do is you multiply this negative 7 times n again times negative 1. So negative 7 times n, we are going to get negative 7n. Negative times negative, you get positive. 7 times 1, you get 7, like this. Then from here, you say 99. Okay, let's just open the brackets. Positive times everything inside the brackets. Positive times negative is negative 7n. Positive times positive is positive. Then you write 7. This is what you are going to have. So from here, you can collect the like terms. So the like terms, you have 99 and the positive 7. Okay, so you can group these terms together. You can say 99 plus 7 minus 7n. So this positive, I've just moved it with its sign the way it is, and I've brought it here. This is 99 plus 7. So from here now, when we add 99 plus 7, what are you going to get? We're going to get 106 minus 7n. So this is our nth term, or this is our general term of an expression. Remember, it has this answer. Okay, so this is how we find the general term of an expression. I hope this is clear. Okay, so I hope it's clear. Let us now move on. We look at other examples. All right, so this is another example. So find the general term expression for the arithmetic sequence 6, positive 2, negative 2, negative 6. So here we are asked to find the general term expression. Okay, we are told to find the general term expression for AP. This is the sequence. So the sequence that we have is 6, positive 2, negative 2, negative 6. So first thing, we are going to write our formula. Okay, we can say nth term equal to, our formula is a plus, open bracket, n minus 1, then times the common difference. If you want, where there is a, you can even put a 1, meaning a1, term 1. Okay, this a1 can stand for term 1. It's fine. Again, for this nth term, okay, for this nth term, if you want, you can say a subscript n, because a subscript 10 can be read as nth term. Okay, so now from here, let us try to organize our data. Remember, we are finding the general term expression, so this n is not going to be substituted with any value. So our term 1 is a 6. Okay, our term 1 is a 6. Then our common difference is found by term 2 minus term 1, or I can say term 3 minus term 2, or term 4 minus term 3. I'll still get the constant value. So our common difference here, our term 2 is this 2, positive 2, minus our term 1 is a 6. So 2 minus 6 will get a negative 4. This is our common difference. Then our n, there's nothing there. So we are going to substitute on term 1, which is 6, plus n minus 1 times our common difference is a negative 4. I've just substituted. Where there is term 1, I've put 6. Where there is common difference, I've put negative 4. Where there is n, we leave it the way it is because we are finding the general term. So from here, we are going to say 6 plus, so we can open the brackets by multiplying with a negative 4. Negative 4 times n, we are going to have negative 4n. Negative times negative, positive 4 times 1, it's a 4, like this. Then from here, we can 6 positive times negative. We open these brackets now. Positive times negative, we are going to have negative 4n. Positive times positive is positive 4. So from here, let's just collect the like terms. We are going to have 6 plus 4. The like term of 6 is a positive 4. So I've just put it here, then minus 4n. So from here, I'm going to have 6. 6 plus 4, sorry, it gives us what? 10. So this is 10 minus 4n. So this is our general term of an expression. That is our answer. Okay, so this is our lesson 1. Okay, this is our lesson 1. Let me just now give you an exercise. You try to work out. All right, so this is the task that you can try to work out. So you have question 1 and 2. So question 1, find the 40th term of the arithmetic sequence. Okay, 1, 5, 9, 13. So you need to find the 40th term. Okay, then number 2, okay, find the general term expression of the arithmetic sequence 3, 5, 7, 9. So this is just our lesson 1. Okay, so make sure that you go through this work, you answer. Okay, then I'll post lesson 2 very soon.